we go. Hi, everyone. Thank you so much for joining us today. My name is Ashley Koff. I'm a registered dietitian and the host of the show for today. And I just want to say thank you so much to, I was actually just sharing this with Dr. Fitzgerald, to BPP, Brassica Protection Products. You all probably know them as the True Brock symbol, but for generously inviting a conversation around education, help us understand this really exciting, the power of this Epinutrient and the nuances of how we bring all of these together. And you'll learn a bit from Dr. Fitzgerald about, especially as it relates to the thing that's driving. So, everybody's like, okay, the younger you, like, how do I do this aging thing better, and from a health standpoint. So we're going to be talking about that today. Just wanted to share by way of housekeeping. This will be recorded. You will have access to a PDF of the slides. You can get that information. There's a lot of evidence-based. It's one of my favorite things about Dr. Fitzgerald is it's evidence-based, and you're also going to then hear about practitioner experience, as we go through this. So you will get all of that. And if you have any questions as we go through, we also have folks in the questions section here on GoToWebinar to be able to share answers there. But I highly recommend, if you are not already not following her on social media, great content there. Also the New Frontiers from a podcast standpoint. And she's also had Dr. Jed Fahey, one of our co-founders and just an incredible scientist who really, at the origins of all of this incredible work, they did a podcast together. So if you want to dive deep and be geeky with me, with all of us, please feel free to, I highly recommend checking that out. So we will leave time for questions and answers. Please go ahead and populate your questions within. This is, one of the reasons I love hosting is it's a little bit selfish for me because I get to ask my questions first, but they shouldn't trump the questions that you have as well. So we'll go ahead and get started. And just noting from a time frame standpoint. So on today's agenda, what we really want to be looking at is this targeting of epigenetics for improving health span and longevity, the importance of epinutrients and their capacity for favorably influencing, and really looking beyond influencing biological age and gene expression, and then a spotlight on the Brassica constituent bioactives as extraordinary epinutrient powerhouses. That's a mouthful, and you're going to learn about what your mouth can and should be full of. Okay. So if you haven't met Beam before, I am on a mission to help people get and stay healthy, powered by their better nutrition. So really, my entire practice, my experience has been around personalized nutrition. Today, I have a company called the Better Nutrition Program, where we are scaling personalized nutrition for both practitioners to make it easier with our tools and also with our programs that consumers can purchase or practitioners can use to as an extension of their practice to be able to bring people, not just to help them identify their better choices, as we're going to learn about today, but really to figure out how to make those choices more often. So would love to connect with you on that. And then I have the privilege of introducing you to Dr. Kara Fitzgerald, whose bio could literally be in all the different things that she's doing and loves to talk about, et cetera. It could be, 7 or 8 more slides. I really wanted to hone in on this younger you, and especially the Younger You program as we're going to learn about it. But for me, what has been so powerful is this research side, this groundbreaking work in an 8-week study that really looked at a 8-week study, a 3-year reversal of biological aging. So how do we even assess biological aging? And then what can we do to make those improvements? And some of those things, in addition to the book that she has, she also has companions that really help us as practitioners make this deliciously doable for individuals, like better broths and healing tonics, which I love. I've been so happy to dive into that. And as I mentioned before, podcast, teacher, and runs her practice. And so what we're going to hear from her today is really this deep dive into epinutrients, biological aging, understanding all of this. As I mentioned, tons of research will be shared, so we'll move at a clip. But as we're going through it, I want you to understand that everything that she is talking about, she also has built a program that makes this accessible so that if anyone is interested in doing this themselves or interested in referring this over to their patients and working collaboratively, you absolutely can do that as well. So welcome. Hi, Dr. Cheryl.
It's great to be here. I'm really excited to be with you today. Okay, let's talk about just really transforming the way that we think about disease. Next slide. We have, I mean, and I would argue even in functional medicine to a certain extent, even though functional medicine is it's systems medicine. It's the clinical application of systems medicine. So we're looking at whole person, but we can silo. So we can think about heart disease, and then cancer is here, and autoimmunity is over here. Gastrointestinal diseases are down here. We can silo things even as we're practicing this systems medicine. Well, and certainly in the greater medical model and the greater research model, we're looking at diseases as these chronic diseases as separate entities. And yet, when we look at the underlying driver, the single biggest risk factor for all of these, and this is this is an extraordinary figure below. This is from Matt Caberlin, a biogerontologist. Aging is the biggest risk factor for all of these. It dwarfs, if we look at cancer, look at the aging bar as compared to smoking, specifically relating to all cancer, or alcohol or obesity, things that were very clear are huge risk factors. We can see that aging dwarfs it. So aging is the biggest driver for the chronic diseases and really acute ones as well. Look at COVID-19 is obviously we're painfully aware of aging as being a huge risk factor here. So if we were to begin to change the paradigm, begin to think about actually looking at aging itself and looking at whether we can change the aging journey, we could revolutionize the practice of medicine across the board. This is from Sinclair and colleagues in 2021, where they crunched numbers on what they think the savings could be if we slowed aging down by a year. And in US dollars, $38 trillion savings. And this isn't just in medical, this is in medical and all things associated with aging. And if we were able to slow it by 10 years, $367 trillion. This is an insane amount. This is the gross domestic product of probably many countries rolled together. That's how expensive, that's how much spend there is in sort of uncontrolled aging, and that's the potential for savings if we could actually slow it down. So can we slow aging down? Can we reverse aging? Next slide. Can it happen in reverse? Let me underscore that. Let's talk a little bit about epigenetics as I get to the answer to this question.
I know we have a variety of people in the audience, but can you do me a favor and just define the word epigenetic as we enter into this part? Because I feel like we may not have everyone in the same definition. Yep.
Yes. Oh, it's nice to have you there and have you with me, Ashley. Yeah, of course. And again, feel free to interrupt and ask clarifying questions or whatever you need to do as we move through. Yes. So epigenetics is epi, above, genetics or genetic material. So this is what's happening sort of above our genome, above our DNA, literally sitting on top of our DNA. These are the biochemical marks that dictate what genes are on and what genes are off. So we've got the same DNA in all of our DNA carrying cells in the body. It's the same stuff everywhere, right? But my eye cell is really different, than hair or my tongue or my heart or my liver. Our cells are radically different. And that's because of epigenetics. That's influencing what cells, what genes are on, what genes are allowed to be on, so that my retina cell can actually be a retina cell and be involved in seeing, whereas my cells on my tongue can be involved in tasting. This radical differentiation between cells, all housing the same DNA, comes down to what genes are allowed to be on and what genes are allowed to be off. And that regulation is epigenetics, is all things epigenetics. And there's a number of ways that our body creates allowing genes to be on and off a very fundamental and important and well-researched epigenetic mark is called DNA methylation. And you can see that little DNA methylation group, that pink arrow, yeah, where Ashley's pointing to it. And you can see the little carbon and 3 hydrogens. So if you go way back to high school chemistry, remember your carbon and there's 3 hydrogens on it. And this is just a fundamental regulatory molecule that our body uses all the time, all over the place. And it pops a methylation group onto the promoter region of a strand of DNA, the promoter region of a gene. And when there are enough of those little methyl groups on the promoter region, that gene can't be turned on. And so DNA methylation is what we're focused on in my talk today. It's what my research is focused on. The other epigenetic marks are also incredibly important as well. But interesting characteristics about DNA methylation, I'll just point out, are, well, one, in the science end of things, we're able to reliably look at DNA methylation patterns. So we're actually really able to reliably test the changes in gene expression as dictated by DNA methylation. But another really interesting and cool thing is that our body kind of preserves and uses DNA methylation perhaps more intentionally than other epigenetic marks. So as our cells divide, and the DNA methylation marks can be preserved or through cell division after cell division. And what this actually means, which is pretty wild, is that DNA methylation marks are inherited as well. And I'll mention that in a couple other slides. So some of this information sitting on our DNA in the form of these DNA methylation patterns can be passed on to our offspring. And we've actually inherited some of this information from our parents and our grandparents and even generations before that. It's incredible. Okay, next slide. Was that sufficient, Ashley?
Oh, fantastic. Thank you. Because, yeah, it's, the lexicon. It's good for us to, I've had vegetarians that define it 27 different ways. So it's like, let's go.
Yeah. Okay. And so this is a little, again, another strand of, some DNA, and then you can see the little yellow blobs on there. Those are methylation. That's the methyl groups hanging around on that DNA, just inhibiting it. Going back to the whole aging phenomena, when we look at changes to DNA methylation on the genes, man, it is remarkable. We can look, so at the top where that blue arrow is, this is a young genome. And the red lollipops are the methylation groups here, and the white lollipops are the absence of methylation groups. And so you can see the young has, in the promoter region, there's less red lollipops than in the older, elderly isn't a great word, but the older genome. So if you compare these guys side by side, a younger epigenome looks almost the opposite of an older epigenome. It's as we age, we start shutting genes off, that red region, and then we actually turn on areas of the genome that we don't want on, what they call the gene body, that blue region. And so there's this sort of predictable transformation as we age, and some of those genes we're shutting down, we want on, and those genes that we're actually allowing to be turned on are up to no good in our bodies. In fact, oncogenes are turned on as we age, driving cancer forward. So we want to preserve this younger DNA methylation pattern. Next slide. Now, as I said, these changes happening in the epigenome underscore and drive the chronic diseases of aging. So, for instance, if you look at epigenetic changes associated with cancer, you will see that the cancer microenvironment just takes over genetic expression and shuts down genes that will inhibit its growth, and it turns on genes that will allow it to proliferate. So cancer has been very, very well studied in the realm of DNA methylation, and we know that cancer-driven changes to DNA methylation and epigenetics are huge underlying issues in the whole cancer conversation. And again, I want to underscore, those changes that happen in cancer happen naturally as we age. I mean, it's it's pretty crazy. And there's a whole philosophical discussion we could have as to why that is. Why is our body changing towards, making us vulnerable to these diseases in this predictable way? If we have time, we can do that in the Q&A. It's kind of a separate presentation.
I was thinking, yeah.
It's had a big conversation. It's sort of
Yeah.
wax philosophically about the ethics. So it turns out we can actually measure biological aging by looking at these patterns. So again, you saw that youthful epigenome, sort of predictably different than the older epigenome, and we can actually measure the aging phenomena as it's happening by looking at patterns of DNA methylation. Next slide. And this is extraordinary in the animal model. So this is a paper that is out now in the journal Nature. We need to update that citation. It says it was released in Cell Press in preprint in 2021, but this year it was released in Nature. This comes out of the lab of David Sinclair at Harvard. So what they did, this is just so interesting. They caused aging in mice by scrambling epigenetics, and specifically DNA methylation and demethylation. So red lollipops and white lollipops, they scrambled that and they caused the aging to happen in mice. So these young youthful mice, accelerated. Just imagine a little old mouse. And then they reversed that aging phenomena and restored youth to the mice by reordering epigenetic patterns. And they did this using a cocktail of something called Yamanaka factors, which are which are proteins that regulate epigenetics and are actually used in our body in embryogenesis and early on, and kind of in different iterations throughout our life. But they gave these mice a cocktail of this DNA methylation and regulating proteins, and they were able to reverse aging. It's huge. It's huge. And so what they demonstrated in this study, and they actually showed it in a mouse model of age-related optic neuropathy. So they caused age-related optic neuropathy. The mice were blind, and then they restored youth to the neurons, restored sight, again by changing DNA methylation patterns. So they went right in there with these Yamanaka factors and restored vision, and the neurons were younger. So we are really in a revolution here in biogerontology, and really starting to understand what aging is. And Sinclair and his lab and other labs out there really think about aging as being driven in the epigenome. So if you want to think about root cause aging, it's changes to gene expression as driven by DNA, or as driven by epigenetic changes. And a huge player here is DNA methylation. And just to underscore how big this is, Altos lab, which is based in San Diego, but there are outlets of Altos all over the world, and has these Yamanaka factors I mentioned. It actually, the discoverer, Yamanaka himself, has been recruited to Altos lab. This is a lab that's funded by a handful of billionaires, including Jeff Bezos, to crack the aging nut. And you can bet that they are looking very carefully at these Yamanaka factors and applications for them and moving it forward, and it's huge. They've recruited the best and the brightest biogerontologists around the world, and actually rumor has it that their salary is $1 million starting annually. So yeah, they're recruiting the best and the brightest. This slide actually is referencing being able to measure chronological aging, being able to measure biological aging. So chronological age is how many birthdays you've celebrated, how many trips around the sun. We can't do anything about our chronological age, excuse me. We cannot do anything about how many trips around the sun we've taken. But the rate of aging, our biological aging, that is the most important piece of information we want. Chronological age arguably will be really not interesting in the not so distant future, but biological age, what's happening physiologically, is going to be our priority, how well we're aging. And we can actually measure it looking at DNA methylation patterns. And what's extraordinary is that even though the first test, that's what this slide is speaking to, it's speaking about the first 2013 biological age clock that came out. They tested it. They wanted this biological age clock to be consistent with chronological age. But in fact, it was a better predictor of health and mortality than chronological age itself. So it was very closely correlated with chronological age, but it was a better predictor of health outcome than chronological age. Next slide.
I find this one so fascinating, Kara, because for me, you know, for so long we try, and I would think of like in the weight loss space and some of the medications people are using and things like that today, we often try to say like, hey, there are different ways that you can achieve the body composition that you're looking for, but you know, you really want it to be health gain, not just weight loss. And what's so interesting to me about this is that, you know, we can, as we go down the path, we know in so many of the dietary approaches, as we're going to see in a moment, they're nutrient poor. They're not providing these epinutrients. And as a result, we're not able to, they're going to be aging you at a faster pace. So like your one goal, like, you know, what if you said to somebody, hey, you can achieve your body composition, et cetera. And then I remember from the Better Broths book, and the live that we did on that, your colleague, I thought it was really astute to just say like, hey, what if you, like, if you're able to get these nutrients in, and they also, by the way, are healing and supporting that you're better aging, like look at the win there. So I think this is going to be, we already know this, but this is such a breakthrough in that younger you, in that healthier you, like that combination. So I just love it.
Yeah, it is. It's fascinating. I know. We need to be eating for gene expression. Like we just need to be providing our bodies with that information. Next slide. Now, this is just proof of concept. So this biological age clock, I mean, what do we know? So, you know, maybe it was good in this data set that, you know, Steve Horvath, the developer of it out of UCLA, who's now at Altos, by the way, but, you know, he put this together with massive, you know, biostats and big computer power and showed it to be incredibly correlative. But what about in real life? And so these are centenarians. These are, you know, healthy French centenarians. This study was conducted in France, and they're younger. They're like almost 30 years younger. So 70 is the new 100. So when you measure their biological age in these healthy centenarians, yeah, they're just fabulously young biologically. Next slide. And then we can look in, this is looking at women specifically, and it's the same thing. So they saw accelerated aging in women 90 and older, who were not healthy, who had restricted movement, who had some cognitive impairment, et cetera. And in those who were healthy, they were biologically younger. So it's just, again, it's a proof of concept. It's showing that in living populations, we're seeing these clocks really bear out.
We so rarely see a study that intentionally looks at racially and ethnically diverse, in particular, the cohort of older women. I just was like, boom, boom, you know, on that part. So thank you for sharing this one. Yeah. Absolutely.
Yes, and thank you for just highlighting that incredibly important point. Yeah, this is not just white men.
Right.
Okay, so factors that influence biological age. This is our study. We published this in 2021. We designed a program before biological age was thought to be able to be reversed. So we knew back in 2016 when we first published what we called then our methylation diet and lifestyle, and that's what we called it in our research study. It's now called Younger You, and it's available in that yellow book over there behind me. Yeah, so it was methylation diet and lifestyle back when we first created it. We knew DNA methylation was incredibly important. We knew it was. I was very taken by cancer epigenetics, as I described to you in the beginning, and I'll talk more about and how it hijacks DNA methylation for its own growth and proliferation. And so we first began to build a program around intentionally manipulating DNA methylation with diet and lifestyle, you know, really a long time ago, well, relatively in the world of science, a long time ago. 2016 is when we released it, and we presented this content at the Institute for Functional Medicine and elsewhere. And then we got an unrestricted grant to actually study it. We knew we could look at DNA methylation. I was confident we had changed DNA methylation expression. I felt reasonably, perhaps cavalierly so, but I just my read on the literature suggested that we would change DNA methylation expression using this diet and lifestyle, very intentionally designed diet and lifestyle intervention. But at the time that we embarked on the study, we started on it in 2018. It was believed by Steve Horvath, the father of biological age clocks, that we couldn't manipulate biological age, that it was really basically set in stone. There was some suggestion that, yeah, if you eat healthier, if you're a little better educated, et cetera, you might have a slightly slower age, but it wasn't thought that we could change it. When we were at mid-study in 2019, the first evidence was released showing biological age reversal, and this was in a group of 9 older men who there was no control group, and it was a year-long intervention using growth hormone injections, metformin, DHEA. So, some heavy lifters, especially growth hormone injections, and a long study duration, and they were able to reverse biological age in that population by 2.5 years over the course of a year. And let me tell you, in the world of science, in the world of biogerontology, time stood still when that study came out. It was the first piece of evidence that, in fact, biological age could be manipulated. And Steve Horvath himself was the biostatistician on the study. So he was the one who crunched those clock data, and, he was blown away himself that this was changeable. So this is when our study was rolling, and we had in our endpoints wanting to explore biological age, but at the time, at our study design, I wasn't holding my breath that we would change it because it was thought not to be changeable. So we were one of the very, very first studies to actually demonstrate, to validate what that first TRIM trial showed, and we were actually able to reverse biological age. In our case, our study was larger. It was in middle-aged men. We had a control group, so we had an intervention. Arm, and then we had a group not doing anything. And we were able to show in our study that in just 8 weeks, extraordinarily enough, that as compared to the control group, our study participants got 3.23 years younger. And this was using just a diet and lifestyle intervention. This was using nutrients, sleep, exercise, a meditation, a probiotic, and a greens powder. That was it. Really, really simple for 8 weeks. And I also want to say that we have brilliant nutritionists, which Ashley, of course, our team here, and they worked with the participants. They met with them at least once a week. And I think that we had good study adherence because they had that nutrition support. Next slide. And let me just actually point out that this art, if you look at that little colorful circle there, that's attention that a paper gets. It just was huge. I mean, it's been career changing for me and for my team, all of us. That's a massively high number. Just mind blowing for me. It's currently the top 99th percentile of all research tracked by that particular group. Yeah, pretty extraordinary. We've just published a follow-up to that. So we've just validated our findings in women. It's small. It's a case series. This is in the same journal. So that first journal was Journal Aging. You can get it. It's a free text download. And this case series has what is in the advanced release right now, and it'll be available, on PubMed and at the Aging Journal website itself shortly. And we showed the same thing in women. Actually, they perhaps performed a little bit better. Let me see here. So we were reduced biological age in this study population by 3.6 years. It's not quite apples to apples because our first specimen was saliva and this specimen was blood, and we don't really need to go down that rabbit hole, but the women did awesome, and they might have done a little bit better than the men. But we need larger studies, and we're aware of that, and we'll continue to research it. So it's all very exciting, and we're just thrilled to have this data in women, which, I've certainly seen anecdotally in myself that following Younger You and, in my patients, et cetera, that we do, that women respond to this well. So yeah, they did extraordinary. And one of the things I want to point out about both of our studies is that our participants were healthy, in fact, really very healthy. These women came to us biologically younger at start. So we get their baseline measurements, and they were all, except for one, I think, biologically younger at start, and then got biologically younger even, more as they completed the program. So very validating and exciting for us. Next. Oh, this is just the download of the program. You can take a look at that, the targets, the nutrient targets, and recommendations around that. Next.
Oh, and I love that we've got leafy greens, cruciferous vegetables, colorful vegetables, and the one that challenges me all the time are the beets. So let's dive into these epinutrients. Yes, awesome.
When I was doing my interviews for the book, I had a ton of them, and I would just have sort of a cornucopia of epinutrients I could sort of flash up here. And let's see, I've got rosemary right now, favorite epinutrient, but anyway. Yeah, let's talk about them. So nutrients change DNA methylation, what we refer to as the methylome. Remember that carbon with 3 hydrogens. There's about 29 million, dotting our genes. There's a ton of these little guys, and nutrients influence where they are, what genes they're allowing to be on, what genes they're inhibiting from expression. Nutrients are major. Next slide.
Ooh.
This was the first profound example. This is a 2003 study. This is the most cited study in the history of science, actually. It came out from Randy Girdle's laboratory. And basically what they did, very simply, is that they gave these are agouti mice. They're blonde and obese, and they're vulnerable to heart disease, diabetes, etc. And they're very distinctive looking. And that's because the agouti gene is on. That means it's got no methyl groups. There's no red lollipops on that gene, or minimal, and that gene's allowed to be on, and it makes them obese, blonde, and risk of diseases associated with obesity. And so their hypothesis was, if they hypermethylated it and inhibited it, or could they, and would that change offspring? So they gave the pregnant agouti dams methyl donor nutrients, folate, B12, betaine, and so forth. And what they showed in the offspring was that they absolutely did turn off the agouti gene, and they basically restored a brown type mouse, a wild type mouse, if you look on the right hand side, that it's called the pseudo agouti. So they were able to turn it off. So it was the first and just extraordinary study to show the power of nutrients on gene expression. And let me tell you this, other labs took this on to see the generational influence. So generation 0, the pregnant generation 0 dams receive these nutrients, and there's an influence to gene expression 5 generations out. So if anybody, mic drop, right? If anybody has any question that food influences, gene expression, yeah, look at the agouti studies. And I have a podcast with him also, actually, if you're interested in doing a drill down, and he's going to come back. We're going to talk about some of his more recent research, which is fascinating. Next slide. This is looking at the generational influence of nutrition in humans. So that was a mouse study, and then this is the overcalyx study in Sweden, and this is very similar. And I want to say the interesting thing about this, so we see the generational influence of nutrition, excess nutrient intake, less nutrient intake. I covered this in my book, actually, a handful of human studies, across generations. But what's interesting about this is they showed prepubescent boys having nutrients status as having a profound generational influence. Really pretty extraordinary. So we think about these, prepubescent boys. Perhaps that's a in free time, like you maybe don't need to be thinking as carefully about stuff. But no, in fact, spermatogenesis is happening a lot. Those DNA methylation marks are really taking shape during this time, and it can, what's being consumed can influence. Epinutrients, so nutrients that influence gene expression, lifestyle, together will lead to a younger you. That's what we demonstrated in our study, and I'll give you a little background on that. The diet was designed, as I said, very specifically with wanting to influence DNA methylation. And we call all of these nutrients epinutrients because we know that they influence gene expression. They influence the epigenome, and influence what genes are on and what genes are off. So there's a whole category of what we call methyl donor nutrients, and we packed the diet full of foods that contain these all important methyl nutrients. We did not give supplements. We did everything food-based. So, B12, folate, betaine, choline. Think about places where we can get those. We include liver in our diet for those willing to eat it. Some animal source protein, but not necessary. We have a vegetarian version in the book. Mushrooms, of course, greens, and we did show in our study participants that we significantly increased circulating methylfolate. And again, we did not use vitamins to do that. Next slide. So those are the methyl donors. The methyl donors are going to help make those red lollipops that I showed you. But now we don't want red lollipops to just go anywhere. We want red lollipops to very intentionally turn genes off that we want off, and we want genes that the protective genes, like the genes that protect us from getting cancer, we want those to be on and humming along. We want all important genes like NRF2 to be on, this potent antioxidant gene, or glutathione transferase genes. We want those important essential genes to be allowed to be on, and we want pro-inflammatory disease-driving genes to be inhibited. Really, I think it's that simple. So yes, we need the red lollipops. We need the methyl donors of that previous slide, but then we need these traffic directors. These are what we call, they're also epinutrients, but colloquially we call them methylation adaptogens. But they're directing. They're not directly making the red lollipops, but they're telling them where to go. They're telling them where to go. And the literature on this really suggests that is in fact what they're doing, that they're helping us have a complement of DNA methylation patterns that are healthful. And our study suggested this as well. So we didn't see, as compared to our control group, a net increase in overall red lollipops, but what our study demonstrated was there was a rearrangement of where those red lollipops were to a more healthful and youthful pattern. And yeah, sulforaphane, is it one of the key epinutrients? Yeah, it is. I'm quite bullish on the power of sulforaphane, and I think that when Jed and team start to include some of these DNA methylation panels in their investigations, that they'll be validating this for us and publishing on this. And yeah, I think looking at biological age and sulforaphane's influence is important, because we already know that it's an anti-aging molecule via a variety of mechanisms, but also these nutrient responsive genes sulforaphane is playing a role in. So yeah, I do think it's, is it arguably the most important? I think it's a really key player. Next slide.
I'd say it's the most important if you're not, it's like, is breakfast the most important? If you're not getting it in, or as we start to, explore, and certainly we have a ton of other information, if you've got certain things going on, as you look at your genetics and other pieces, but, if you're not getting it in, then it is the one, the most important on that part. We've actually seen some great work with it in blood sugar optimization too, just, with continuous glucose monitors. I think what you're saying is, as the research starts to get to this place, just like you've been able to do it with your, your biological aging test, like as we start to look at the inclusion of these nutrients and then measure them, the data with, better understanding of, to see it, it's going to be fascinating for us. So yeah,
totally fascinating. And there's just a handful of like kind of sexy methylations, epinutrients that are just rising up to the top and showing themselves to be really powerful and important. And I would say curcumin is one of those, sulforaphane is one of those. Like they just seem to be extra special with the research right now. Okay, so next slide.
Yeah.
And there it is. There is the lovely molecule of sulforaphane, a key epinutrient. Next slide. These are the nutrient responsive. So again, there's 29 million of these red lollipops, also called CPGs, but you can think of them more colloquially as red lollipops. And just as I said, cancer takes over the tumor the epigenetic expression and inhibits protective genes and allows genes that drive disease forward, oncogenes, to be turned on. And these genes, I've termed them nutrient responsive genes, and there's a table of them in the book, and I just pulled a page out of that table to show you, another reason why I absolutely love sulforaphane, but there's other very important molecules as well. Next slide. So these are nutrient responsive genes. Look at BRCA1 and 2. So we know BRCA1 and 2 when there's a mutation in the BRCA gene itself, a mutation. This is different than it being hypermethylated and inhibited. So I want to make that clear. A mutation in BRCA1 or BRCA2, it has a potent association with cancer, and the older you are, the more likely you are going to get cancer. In fact, that's why Angelina Jolie had, prophylactic mastectomy and full hysterectomy, because she has the BRCA mutation, and her mom died of ovarian cancer, I think, when she was in her early 50s. So she has the BRCA mutation. However, BRCA can be hypermethylated and inhibited. So it acts like it's a mutation, even though it's not. So it's a fully functioning BRCA protein, but it's not able to do its tumor suppressor activity because it's hypermethylated with those red lollipops and it's turned off. So if you look over on the right-hand side, you can see nutrients that have been demonstrated mostly in vitro studies, so mostly in cell studies. We need more, we need more in vivo, but some in vivo studies that it will turn on BRCA. It will turn it back on and allow it to be functioning. And you can see sulforaphane is one of them. EGCG from green tea is another. And then if you look at the just below, the 1011 translocation enzymes and DNMT, these guys can be hypermethylated and inhibited as well. And in so being will drive cancer forward, and they can also drive other aging phenomena forward as well when they're inhibited and they're not able to do their job. And again, sulforaphane has been demonstrated to be able to turn those hypermethylation, those imbalance, those disease-driving hypermethylation patterns around. And if you looked in the book and you saw the others, you would see that sulforaphane figures, broadly in a number of these. Next slide. So we want this in our diet, and it's sulforaphane. There's evidence that suggests, actually, the previous slide, this slide, that it allows for re-expression of tumor suppressor genes by inhibiting hypermethylation from happening, by inhibiting the placement of those red lollipops. But I want to be clear. We want red lollipops to turn off certain genes, like the oncogenes that drive cancer forward. We want that to be packed with red lollipops, but we want the promoter region of important genes to be free and allowed to be expressed. We want our anti-inflammatory genes on. We want NRF2. In fact, sulforaphane helps NRF2 not only turn on NRF2, but it also helps keep NRF2 functioning by changing methylation patterns. So yes, in the broad stroke, it seems to inhibit the placement of red lollipops, but I want to say it seems to do it with some intelligence. They're just not willy-nilly. Sulforaphane is not willy-nilly blocking red lollipops, but it seems to be doing it with intention. And again, I think that's what our study expressed, and we'll look at the data here. Next slide.
I think that's so important, because we're really, and going back to like how you guys were able to do this, that you didn't do it with, a bunch of medications. What we've seen over the years with, COX-2 inhibitors or statins or others, when you fully shut something off, you have this downstream or upstream, huge challenge, right? Where you are, wait, the good stuff, like we need some inflammation. We want that to occur. We just want it to occur strategically. And one of the things I love when Jed presents is he always talks about just the plant intelligence of how the broccoli is designed, with that, the sulforaphane and the glucoraphanin and the myrosinase pocketed near each other, but not together, so that it's not until there's the need, for them to combine to produce that sulforaphane. And as you're talking about, it's this intelligent way that it addresses expression and suppression, that, we're really, our food is again, is just more intelligent. We obviously have needs for targeted medications, but our food can do it in a much more intelligent way, in an adaptogenic way, certainly with certain herbs. So thanks for bringing that up. I think that's really powerful.
Well, and I appreciate you underscoring it. It's incredibly important. And the more sophisticated tools that we're getting, the more we're able to actually demonstrate that. And that's where we are with the ability to look at epigenetics with this level of sophistication. You can look at these potent changes. And I want to say, so yeah, drugs for sure. There's a whole, there's a family of these demethylating agents that are used in that are chemotherapeutics. They're used in cancer, and they just willy-nilly strip methylation. So you can imagine by doing that, there's going to be a whole horrible cocktail of side effects, because they're just, allowing all sorts of genes to get turned on in this way. And yeah, the side effect profile of these drugs is pretty nasty. But I also want to say that on the continuum is vitamins, and that's one of the reasons why we opted not to use them. So if I take an isolated B12 and an isolated folate, it's pushing similar, just as that agouti mouse study showed. They gave the isolated nutrients, and they showed 5 generations out influence of those vitamins on gene expression. I mean, that's astonishing. So I think this era where we're able to look at the omics, where we're able to look at gene expression, brings this heightened respect for food, nutrition, for food, for sophisticated nutrient combinations, like what's in a forkful of salad, like the density of information in that, and the influence of the microbiome on it, and systemic absorption, and then ultimately the influence of gene expression on that, and the aging phenomena. It's just extraordinary. So this is one of my favorite studies. It's an older one. I think this was accepted and published in 2013. But it's so cool. So they used sulforaphane's cousin. They used diindole methane in this study. And if you're getting whole cruciferous, or if you're doing like seeds or sprouts, you're going to be exposed to diindole methane as long as your body can produce it. But they used a DIM product in this, and they showed that it turned on it turned back on suppressed NRF2. So the NRF2 gene was hypermethylated and inhibited, and DIM turned it back on. And we know actually from other data that sulforaphane does that, and perhaps it may actually do it a little bit more potently. So they showed that in cells, that DIM turned it back on, but then they actually went and looked in mice, and they were able to corroborate that in so doing, in allowing re-expression of tumor suppressor genes, these protective genes, they were able to shut down tumorigenesis in the mouse treatment group. Next slide.
And I just want to acknowledge, Kara, I'm so like diving in and geeking out, and of course then asking questions. We have about 13 or 14 minutes left, and I know we've been answering some questions. If we don't get to your question and you have a burning question, please go ahead and ask it, because we will follow up and answer that question. And also, just a reminder, you can head over to Kara's Instagram, I think is probably the easiest, and ask any follow-up questions there, and you will also get the slides sent over. So I want you to keep going with this, because there's just so much great information, but just wanted to give you the timing. Yeah.
Awesome, thanks. Yeah, and actually we're on the slippery slope home here, because that was the last. I think that was the last slide that I wanted to dive into. Okay. But now we're looking at broccoli and prostate cancer, and this was actually not a particularly aggressive intervention. I think they could have turned the broccoli exposure up in the participants, but they definitely showed a trend towards protection. So you can go past this one. And then we also see using sulforaphane specifically in oxidative stress and asthma and allergy. I mean, if you look in the oxidative stress in the lung compartment of those asthmatics, it's just massive, and sulforaphane significantly dropped it. Next slide. So by turning on those phase 2 enzymes. And this is sulforaphane's effect on aging more broadly. There's something called the hallmarks of aging, which many of you may be familiar with, but they're the collection of pathophysiologic changes that happen in the aging journey. And we have a blog on it, actually, somebody can post. We have a plain language, easy to read blog on it. Epigenetics sits at the top. We think that epigenetics may be the root of the root. So all of the hallmarks epigenetics is up there, but we can see sulforaphane influences potently epigenetic regulation. It maintains collagen in skin. It delays cellular senescence, helps with stem cell renewal, and antioxidant defense. So it casts a wide net in addressing all of these hallmarks. Next slide. What else influences the methylome? So I want to say again, I just want to hit home that yes, nutrition was center to our study. And over on the left-hand side there, you can see the other variables. Sufficient sleep. I mean, there are data on this. Exercise is like eating your broccoli sprout. I mean, physically, it's like making your broccoli sprout, like movement. It's so
Farming.
potent.
Yep.
It's so potent specifically on epigenetics and DNA methylation. In fact, the older we are, the more influential it will be on favorable changes. It will turn on those tumor suppressor genes, just like I talked to you about sulforaphane doing. Exercise will do that, so it's important. And what else? Taking care of your gut microbiome, turning down the stress volume with some meditation, all of these things. And again, I cover the science in the book. Next slide. So our goal with this research, this isn't Yamanaka factors, but we are looking at DNA methylation in the same, we're attempting to optimize that. We think that we can create a longer lifespan, a longer health span, and perhaps an easier, less grueling time experiencing the diseases of chronic aging. So now the last 16 years of our lives are spent with multiple chronic diseases, polypharmacy, spending our last dollars in life, in assisted care facilities, et cetera, our family needing to make really difficult decisions and care for us, et cetera. I mean, the whole aging journey in this country is just depressing, tragic, and so difficult. And we can change this by addressing biological aging and by looking at slowing it and optimizing health span concurrently with that. Next slide.
Oh yeah, I had asked you just if you had a second, and it's basically, I think I even mentioned it, where we were talking about glucoraphanin and myrosinase, because I get a lot of questions about sulforaphane. You've talked a lot about this as a nutrient, but just reminding people that you don't find sulforaphane pre-formed, that it's, through the body's process or, et cetera, on that part. So I just had thrown this slide in here if you wanted to mention it or not.
Yeah, no, definitely mention it. Yes, we need to be able to make the active compounds, and we want to have some understanding of how we're doing that.
Yeah, awesome. And I think, as we just kind of close out and get those questions ready, because I am going to go over to the Q&A, and I know we've got one or two that were already there. One of the things that I, again, just so grateful to Brassica, BPP, and TrueBrock for allowing us this opportunity to bring in Kara to have this conversation. And the real question that many of us are leaving with it now is like, but how? There was a whole list of nutrients, like, there's a whole rainbow to get in. Then after the nutrients, there's like, how do I get in cuddling and take care of my gut microbiome and all of these different pieces? And I wanted to share, in a moment, I'll share about Kara's program and the fact that they're accepting people right now. So this is really time sensitive. I wanted to also answer a question that I often get, because this conversation about supplements, as you were talking about, an isolate in there, where's the value? And there's no question that there's tremendous opportunity with seeds and sprouts, and even broccoli florets. And you mentioned the indoles, et cetera. But when we look at the glucoraphanin and the body's ability to, and especially when we're trying to be targeted with it, based on all of the plethora of research that Dr. Jed Fahey and others have done, is how can we as clinicians do that consistently? And what I found personally and professionally is that this is something that's so important to me, that I try to do the things that you guys are teaching and recommending in your protocol, but also I like that constant support. And so that's really the role of the supplementation, but looking for a supplement that is standardized, that I'm very clear about how that glucoraphanin has been extracted, working on my digestive health to make sure that I have the available myrosinase. So let's not kick the broccoli florets out. They have so much value nutritionally. If you tolerate broccoli sprouts, and as Kara mentioned, if you can grow them yourself, like you get the added benefit of both being in nature or doing activities and things like that, and you're going to get value. But for many of our patients and at many different life phases, moving to the supplement side. And so when you see the TrueBrock logo, you can know that that's the standardized water extracted form that we are talking about, and that's based off of the Johns Hopkins research. So I wanted to share that. And as a way, a lead into.
Let me just say, I just want to underscore a couple of your comments. So in our study, we were very mindful of wanting to turn the volume down on the supplement influence. So we used a greens powder, which you can bet included a lot of cruciferous, and we used a probiotic. But in fact, in real life, and this includes me, I lean on well-designed nutrients. There's a handful that I take. I don't drink enough green tea, so I take a green tea extract. I, without question, take sulforaphane. I mean, I'm actually using, I don't know if we're naming brands, but I'm using the Thorn product, which you know, you guys are the source material for it, and curcumin. You know, if I'm not able to get enough turmeric in my diet, and I'm prescribing these similarly. So there's absolutely a place for this in our younger you paradigm, beyond what we did in our study.
Right, totally agree on that part. And with travel and access, you know, food access, different times of the year, or it's really important for me. And like you mentioned, tea, it's really important for me to have organic, you know, and those kinds of things. So the nice part is, and you mentioned, and this is an opportunity for me to brag on my colleagues, you mentioned that, you know, you have this program and that so much of the value, I think when people try to go out and do this, and they could read your book and go out and they could do the BioH test, and it comes with a 30-minute consult. And so you've got all of these opportunities. But if you join the virtual group, which I believe starts in April, so it's great timing, especially going into the summer, you know, and all of this stuff. And remember that the research that Dr. Fitzgerald has been sharing is, you know, it's reduction of a couple of years of age, of biological aging in weeks. I should say in months, because it's like 8 weeks, but we're not talking about like, hey, you have to transform your entire life. Number one. Number two, you don't have to like do all of these crazy things. It's food based. And then as we learned, there's also lifestyle choices. So just wanted to share this with you again to pass on to practitioners, colleagues, as well as your patients on that part. Okay, so, and I'm going to pivot us over to questions because I know we've got a lot of them. I also just want to acknowledge the brilliant team members that you have, including them on here. So I just want to share that. And then just as a thank you from Dr. Fitzgerald, and we also have the TrueBrock team, and if you have anything that we can help you with, we've got that part. Okay, so let me come over to questions, and we have about 3.5 minutes, Kara, so I'm just gonna have you take them away.
Rapid fire.
Should an aging population take higher doses, and notice the wording, take higher doses of sulforaphane? So I'm curious how you'll respond to that one. Yeah.
God, that's a great question. I don't know. So the best way to answer that is to join us in our class. You know, I would do, I mean, it would just, like, you want to look at your biological age and then you can dial it in for where you were. So the fact that we have these tools available to us, I think is the best answer. And you, Ashley, may be able to speak to the work that Jed's done. Actually, Jed, you could maybe just type a comment on whether or not you've seen dose-dependent benefit and, you know, age-related dose-dependent benefit. My suspicion is that you're going to get away with exactly what they studied.
Right. Well, I think there's probably two things that I want to comment on that part. The first one is that aging, like, I mean, really what you've heard from Dr. Fitzgerald here is it's not a more is better, a higher amount of this, or especially taking of a product. So we've talked about broccoli seed sprouts, we've talked about you know, getting in your broccoli, beets and all these other things. And so I think, you know, we don't want to jumble aging in entirety and not look at personalization. So my recommendation would be to go the route at minimum of getting your own BioH test. And then really it may be that before you start, you know, going with a higher dose of something, it might be optimizing your digestion, or it might be identifying things you're not getting in, et cetera. But you don't want to say, hey, I'm aging, and so I want to take higher doses. We can. Yeah.
And these nutrients work in symphony. So you really want this massive complement of them, and they're very sophisticated interactions with each other, with our digestive tract, with our microbiome, and then, you know, in circulation. So yeah.
And I want to answer a very important question and mention that if there is any issue whatsoever with this, please, anyone listening live or watching this, go to Instagram or go to send a message through this website. Somebody was saying that it's not available on Dr. Fitzgerald's website. Try going to youngeryouprogram.com.
That's not available.
Yeah. They were just saying, can we get access to the Diet, Lifestyle, and Methylation book? It's no longer available on Dr. Fitzgerald's website. Yeah.
That's right. No, the book has been supplanted by the much better younger you. There's so much more
Okay.
in the younger you than our original 2016. I mean, the literature has evolved at a breakneck pace. So
Got it.
the book is up to date in the science, more so than the original MDL. Yeah, the original MDL was written in, between 2013 and 2016.
Two more quick questions. I know we're running out of time. Is sulforaphane good for cognitive decline?
That is I mean, I think the evidence suggests yes. I don't know that it's been directly studied on cognitive decline, so this is for you, Ashley, but when you look at all of the hallmarks of aging that sulforaphane independently improves, it's so extraordinary. Cognitive decline being, one of the top 3 issues associated with aging. If we, in its ability to favorably influence these hallmarks, I would anticipate that we would see it.
Yes. And we actually did a study. We had a conversation that's available at the website, or you can just request it from us on social or in any of the emails that you got as an announcement for today, with Dr. Romy Mushtak, who's a functional medicine neurologist. And then also there was another one, I'm forgetting the title, where Jed, we actually had to stop and not be able to go over into that whole area where we talked about it, but he gave this great graph of NRF2 and looking at sulfur or pathways, on that part. So the shorter answer is yes. I think the long answer is we don't have the time here to go through that, and I wouldn't feel comfortable, but I know that there's some really important information, so I do want to be able to share that with you. And then I think the sulforaphane good for hormone balancing, female aging, hormonal changes. I think you actually saw that in your younger you, your smaller study, the more recent one, correct? Like that improvement in biological aging.
Well, you know what? I was actually gonna share my own hormone, my own Dutch results that I had recently, to just sort of demonstrate the power of using this whole nutrient approach that's sulforaphane forward by design for me, to show hormone metabolism and how, just how fabulous it looks without, again, B12 and folate. I wasn't using any of those whole vitamins. I was just a food forward approach with some select supplements, these epinutrients, these polyphenol compounds.
And then, of course, I love that somebody asked this. This might be a to be continued, and we may share something, but they're asking any special discount, especially if they attended live, for the Younger You virtual program. So just noting that.
You can bug my team.
That's right. That's what I would say.
It's actually pretty discounted. By the way, I want to say it's a phytochemical sulforaphane. Let me get my
say it one more time.
Phytochemical versus the polyphenol. Yeah, structural.
Right. Yes. Wonderful on that part. Okay, well, I just want to take this opportunity. I'm not going to get into brand names and products and things like that. I don't think that's a win for us to dive deeper into that, and we are over time. So if you have any questions, feel free to reach out to Dr. Fitzgerald. There is a time sensitivity to the Younger You, the virtual group, which starts around April 20th. So definitely, if you're thinking about this, don't wait.
Come. I would love to see you there. I will actually be hanging around and lurking and just available to ask questions and so forth.
Oh, well then no discounting, because that definitely doesn't cover your hourly, my dear.
Well, and our team are seasoned veterans in administering this in the research setting. They know this inside out.
Yes, and at making things deliciously doable, which speaks to me on that. So I just wanted to acknowledge, again, Brassica, TrueBrock. If you have any questions about this, or you're interested in more of the research or prior conversations that we had, please feel free to head to either of these websites to get that information. And again, too, if it's just easier for you to respond to any of the emails that you received about today, please do that, and we'll be able to get it where it's supposed to go. I just want to say, Kara, to you and also to your entire team, this has been such a team effort project. Thank you so much. It's just such a privilege to have you spend the time going deep in the evidence, and I also think the economical implications. I mean, that totally blew my mind. Look, from a policy standpoint, thank you. It's just so exciting, and we can't wait to see more. I believe you have one of the studies that is also newly being published. Is that right? There was one that was.
Yes. Our study looking at women is like is live today in the advanced release on at aging at the journal.
Wow. See, we timed this perfectly, everybody. So make sure to check that out. Make sure to share it. Spread the word of Younger You. And just want to say again, thank you to everyone. And thank you all for spending the time with us today. Really, really appreciate it. Of course, you will get the materials so that you can go back to it. Yes, and there is a request, Kara, for you to teach professionals the Younger You program so they can apply it to their. Yeah.
Yep. Good. Good. Yeah, that's coming. Definitely
Good.
let us know. Any professionals out there interested in the training, just, give us a shout out. Kara at Dr. Kara Fitzgerald.
Wonderful. Thank you so much, everybody. Take care.